Hey guys, today we're going to be learning about simple interest and compound interest and what the difference is between the two. Okay, so first up we're going to be looking at simple interest. So Janet puts $1,000 in her bank account. It has an interest rate of 10% per annum and she leaves the money in there for 5 years. So we're going to be using our simple interest formula that we looked at previously in another lesson. And that formula is I is equal to P times R times T. So I stands for interest. Our P is the principal, R is the rate, and T is the amount of time. Okay, so we need to have a look at our question and figure out which is the P, the R, and the T. So our principal is the $1,000. So that's how much Janet's put in. Our rate is the interest rate, so that's our R. And then T is time. She leaves it in there for 5 years. Cool. So in order to calculate interest, it's going to be I is equal to P times R times T, and I'm just going to put these three values into my formula. So I is equal to 1,000 times the rate. Remember, always write the rate as a decimal, so 0.10 times 5. So the interest that Janet earns is $500. So at the end of her 5 years, she'll have $500 extra as well as the $1,000 that she's put in. Now let's look at that same situation with Janet and her $1,000, but this time we're going to be using compound interest. So compound interest is basically where you earn interest on the interest that you've already earned. So essentially, the longer your money stays in the bank, the more money that you make in interest. So let's do this example and hopefully it will make a bit more sense to you. So Janet has $1,000. It's earning an interest rate of 10% per annum. She leaves the money in there for 5 years. So in her first year, her principal is $1,000. Now the interest that she earns in that first year, it's P times R. So her principal was 1,000 and the rate was 10%, so 0.10. So the interest that she earns is $100. Great. So then at the end of the first year, all up, she's got her $1,000 principal plus $100 of interest, so she's got $1,100 at the end of her first year. Cool. So then at the start of the second year, she doesn't just have $1,000 anymore. She's actually got $1,100 because she's got her principal plus her interest. So we're going to put that in our box here. So she's got $1,100 at the start of the second year. Then to find out how much interest she's getting, we're multiplying P times R. So 1,100 times 0.10. So in the second year, she's earning $110 of interest. So that means at the end of the second year, she's going to have $1,210. So then at the start of the third year, she's got $1,210 sitting in her bank account. She's going to be earning 10% on that. So 1,210 times 0.10. She's going to earn $121 in interest in her third year. So that means at the end of her third year, she'll have $1,331 in her bank account. Cool. So at the start of the fourth year, that's right, you guessed it, she'll have $1,331. She'll earn 10% on that, 1,331 times 0.10. So in her fourth year, she will earn $133.10 in interest. So by the end of the fourth year, she'll have her principal plus interest, which will be $1,464.10. So at the start of the fifth year, that's how much she has in her bank, 1,464.10. She's going to earn 10% on that, so 1,464.10 times 0.10. So in her fifth year, she'll earn $146.41. So that means at the very end of her 5 years, when she goes to take her money out again, she'll have a total of $1,610.51. So now if we compare that to what Janet would have earned through simple interest, you'll notice that the amount is quite a bit bigger than what she would have earned. So with simple interest, she only would have earned $500 all up, and at the end of her 5 years, in her bank account would be $1,500, whereas with compound interest, she ends up with $1,610.51. So she ends up with $110.51 more than she would have with simple interest. And the reason for this is because you'll notice that every year, the interest that she's earning is slightly more every year, because the principal and the interest get added together, and then that's the new principal for the start of each year. So now let's look at another example. So here we have David. He's investing $20,000 at a rate of 13% per annum for 5 years. So we're going to use our simple interest formula for this one. So I is equal to P times R times T. Our principal is 20,000. Our rate is 13%, but we have to write it as a decimal, so 0.13, and it's 5 years. So David, at the end of it, will have earned an extra $13,000. So by the end, sitting in his bank account, he'll have his original $20,000 plus an extra $13,000 all up in simple interest. So here we're going to look at the compound interest. So David's got his $20,000. It's invested at a rate of 13% per annum for 5 years. So at the start of his first year, he's got $20,000. His interest is 20,000 times 0.13. That gives him 2,600. So at the end of his first year, he'll have $22,600, and that's then his principal for the start of the second year. So 22600. I'm just going to go ahead and fill out this table. So at the end of the 5 years, David would end up with $36,848.70, whereas that is quite a bit more than what he would have earned through simple interest, where he would have only got $33,000. Now, compound interest makes the biggest difference when it's over a longer period of time. That is when the amount becomes really significant when compared to simple interest. So let's do this example here. So Alan invests $50,000 at a rate of 3% per annum for 30 years. So using simple interest, I is equal to P times R times T. So the principal's 50,000. Oh, sorry, that looks like a 3. 50,000 times 3%, so 0.03 times 30. So Alan would earn 45,000 in interest. So using this method, at the end of the 30 years, Alan would have a total of the principal plus interest. So he'd have $95,000 at the end of the 30 years, all up, including his initial investment and then the interest that he's earned. Now let's compare that with compound interest. Now you'll notice here that this table, I've skipped quite a few of the boxes, but I'm just going to go ahead and fill this in and we'll see the difference. So with the compound interest, Alan would end up with $121,363.12 at the end of his 30 years, because every year the amount of interest that he's earning gets bigger because the principal gets bigger, because the principal gets added with the interest at the end of each year. So you'll notice that as I jump from the first year to the second year to the 10th to the 20th to the 30th, the amount of interest that we're earning by the 30th year is massive. Whereas with the simple interest rate, you're just continuing to earn that same amount of interest from the first year. So Alan works out significantly richer by getting compound interest. So that's the important thing to know with compound interest. You end up earning a lot more if it's an investment. Whereas if it's a loan that you're having compound interest on, you're going to end up paying a lot more than if it was simple interest. So just something to be aware of. Anyway, thank you for watching.